Thank you very much. It's a pleasure to be here. This is my third time speaking at Rise of AI. It's pretty cool from the very humble beginnings to what it become. So today I'm going to be talking about towards an AI commons. And I will preface this with a question. If there was a KPI for humanity, what would that be? Would it be maximizing the GDP of everyone? Would it be making everybody super, super happy? What might it be? And what does that actually mean? How would we measure that? So if we were to become a little bit more pragmatic, what might that mean? Or maybe, does it already exist? It turns out that there is a pretty good KPI, or a set of KPIs. It came out in 2015 by, of all things, the nations of the world agreeing on 17 combined KPIs, the UN Sustainable Development Goals. And these are things like no poverty, zero hunger, and so on, all aiming for this by 2030. Now, in there, there's a lot of talk about the climate crisis and so on, so it's a good thing that about 4 or 5 of these are actually dedicated towards the climate crisis. Climate action, life below water, life on land, and so on. So this has really become a galvanizing set of goals for the United Nations and many NGOs and institutions all around it. Since 2015, there's been growing and growing and growing momentum. So if we want a KPI for humanity, maybe this is it. By the way, they also have about 180 measures to see how well they're doing against these goals. So the one question is then, OK, we have these goals sort of to help humanity for good. Then the question is, can AI help? Can AI help towards these KPIs for civilization, the UN SDGs? Well, if you can look around, and it turns out that there are quite a few projects doing AI in ways that can help the SDGs. For example, satellite imagery can be used to predict deforestation. If you see that things are being more and more deforested, well, once you measure it, that's the first step towards optimizing it and reducing deforestation. Another one is, interestingly, it turns out that once you can measure livestock moving around, it's actually a very good predictor of whether conflicts are going to happen. Basically, cattle don't like bullets, so they run. Another good example is microinsurance for crops. So these are a few examples of AI and satellite projects that are towards these SDGs. There's more. AI for smart communities, smart cities. Things like a tailored smart city where the traffic lights are much more efficient. So if it's midnight and you're the only one sitting at a stoplight, wasting your time, running your gasoline, and so on. So there's a lot of things that can be done there. Or epidemic modeling. When mad cow happened in the UK, every single cow in the USA was killed. But what if you could zoom in and pinpoint to which herd it actually emanated from? And sort of as this movement has been starting to happen, these specific cases, there has been this emergence of a community around it called the AI for Good Summit. The first one was 2 years ago in Geneva. And at that time, there was about a dozen UN agencies that came, as well, including the ITU, which is a telecom arm of the UN, XPRIZE, the ACM, which is a major computer science organization, and more. So it was really about these people getting together for the first time, mostly policymakers, less so developers, but getting together for the first time to say, what can we do to help catalyze this movement, to help make AI improve good rather than just selling more ads. So this has emerged. Last year, it grew. There was about 500 people who came and about 20 or 30 UN agencies. And this year, it's actually happening more. There's going to be 60 plus agencies and more than 1,000 people at this in just a couple of weeks. So there's a community forming around this saying, hey, we can use AI for good. So to the question of, well, can AI help for good for the UN SDGs? Perhaps the KPIs of civilization? The answer is a resounding yes, which is great news. But there's a challenge. The challenge is that of scale. So right now, there's a whole bunch of people out there that have ninja skills for AI. AI researchers at universities, maybe many of you in this room, you're really good at solving problems. Maybe once the problem is solved, deploying it to industry, maybe even scaling it up. But on the other hand, there are the people with the actual problems, the problem owners, maybe people trying to stop deforestation, the people who are trying to stop the next outbreak of mad cow disease, this sort of thing. And these people often don't have good ways to formulate the problems, to put it into something that then an AI researcher can take and work with. So there's this gap between the problem owners and the problem solvers. So the question is, what can we do to resolve this gap? And in resolving this gap, can that make a difference towards scaling up AI for good? So right now, there's sort of a smattering of these AI for good solutions that I talked about, a few of them here, a few of them there. And none of them have really hit massive global scale yet. But imagine the vision of in the next couple of years, there are 50 problems, 50 problems solved in one jurisdiction each initially, but then deployed to 10 jurisdictions, then 100 jurisdictions. So 5,000 AI for good deployments. That would start to move the needle. That's pretty exciting. So how do we get there? Well, going back to this gap between the problem owners and the problem solvers, let's try to address that. What can we do? So we need to flesh out the ecosystem. That's the first thing. So the problem owners, they often have data or access to the people who have data. And then the data owners themselves are storing the data in maybe their own compute centers or maybe on the cloud. And as well, the people solving the problems, running the AI algorithms, they are, of course, talking to the storage and compute services as well. So this is a bit of a fleshing out of the ecosystem. Obviously, it's still simplified, but it gives us a feel. So, and notice that the problem solvers are talking to the data owners and the storage and compute, but there's still this gap. Imagine we start with this, but we say, let's structure it a little bit more. Imagine that we have some sort of connective tissue such that the data owners, the storage and compute, cloud services, et cetera, and the problem owners, all of that is leading as a big fat pipeline towards the problem solvers. So think, as a wonderful example, many of you in the room probably know about ImageNet. It came out of basically a PhD student at Stanford in 2011, I believe. And with that definition of these problems, many, many images and people saying, hey, classify which is a dog, which is a cat, and so on. From that simple problem, it was then well-defined enough for dozens, then hundreds, then thousands of AI researchers to go and attack those problems, right? Using their own resources and so on. So that's an example of taking one problem and making it available to the problem solvers. And it isn't just ImageNet. If you go back 20 years, we have things like the UCI repository, which is a repository of, it used to be about a dozen problems, but now there's hundreds and thousands, or OpenML. So imagine if we had some network that connected all of these, that connected the data owners and so on with the problem solvers. What might that look like? We can think of it as a public utility network. And what is a public utility network? Well, we have the lights around us looking down, shining on us, and that's supplied by electricity. And the electricity is this public utility network, coming from this public utility network, the electric grid. It's just there, right? And we have the waterworks supplying water to us. We have sewage systems. We have roads. All of these are different networks that are public utilities. We also have the natural ones, like the air that we're breathing and the soil that we're standing on. These are all basically substrate for us as humans in civilization. Now, here's the cool thing. There's a whole new breed of technologies that makes it way easier to build global-scale public utility networks. This is blockchains. Blockchains are public utility networks. Now, in the room, probably many of you have heard about things like Bitcoin. So Bitcoin, one way to think about it is simply digital gold. And you might ask who owns it? The answer is no one. Someone created it more than 10 years ago now. They put it out as just a piece of software. Other people downloaded it and started running it. And those pieces of software that were running on different computers started talking to each other. And bit by bit by bit, it went from 1 nodes to 5 nodes to 10 to 100 to 1,000 to now there are more than 10,000 nodes running this Bitcoin public utility network. It is not owned or controlled by any single individual or government or corporation. It's just there. People have established a value on it. You can go on to one of dozens of exchanges and trade it, add Bitcoin for US dollars or euros or otherwise. These days it's worth about $7,000 or $8,000. Goes up and down. But the point is, it's a public utility network, and for the very first time, we have something that is scarce in the digital fashion. Like gold, gold is scarce, except it's digital. And like gold, no one owns or controls it. This is a really powerful idea. It turns out that you don't need to stop at this scarce token used as a replacement for gold. You can use it in a lot of other ways. You can use it to build infrastructure, to start to shape incentives, to start to get people to do stuff. And that's actually basically the superpower of blockchains. So next, here we go. So imagine now going back to this challenge of connecting problem owners with problem solvers. We have a network, just like the internet, just like the World Wide Web, and on top of that, just like Bitcoin, but it's dedicated towards connecting these people, the problem owners and the problem solvers, towards a commons. A commons as in a shared resource pool that anyone can access. Just like we have a shared resource pool right now of breathing this air or access to the electric grid, now it's for data and AI services. And if we were to flesh this out a bit more, this is what it can look like. So this is the most nerdy slide of the talk. So if your eyes glaze over, that's OK. But for the engineers in the room and the data scientists, here's what it can look like. For the problem solvers, imagine you're using your Jupyter notebooks and you're accessing data and storage and compute. If you're a problem owner, you're entering your problem. You're specifying some Excel spreadsheets or CSV files, saying this is a classification problem. And of course, you're working with the AI people for that. And then the data owners and storage and compute, similar things. You're providing front ends for this. And it's all connected in one common substrate that is global, this public utility network. What might this do? Well, the whole thing here is it's all about unlocking the data. We see time and time again, there's lots and lots of people who have AI problems that they're happy to solve, but they have a shortage of data. So if we can unlock data, then we can unlock and equalize the opportunities and benefits of AI. So one thing, imagine if there was 10 or 100 marketplaces for data, or 1,000, buying and selling different sorts of data, medical data, and automotive data, and some of it is free, like a data commons, and some of it is priced. So think like Bloomberg, but instead of just Bloomberg providing data for financial services across the board, and instead of having to hook to 100 or 1,000 different APIs, it's all in this unified way that connects. So you have many, many networks plugging in. So imagine we have this network that just makes all these data marketplaces available. On top of that, you might ask, well, what about this commons data, this free data that could be used to benefit a whole bunch of people? Of course, it costs money to put out there. Here's an example for you. It turns out that right now, if you want to predict the weather, you actually have to have a really good model of global data, of weather data throughout the world. And right now, there's a problem because in Africa, there's a black hole. There's not enough incentive for people in Africa to put up really good weather prediction weather sensor stations to be able to predict the weather well in Africa. What this means is that when we're trying to predict the weather globally and understand global weather trends, it's very, very hard. Now, it turns out that actually, if you're a telco provider, you can actually change your cell phone towers. You can start to gather data on those towers, just a little bit of cost. And then the data that's gathered from those towers, things like the changes in EM going down the lines and so on, this can actually be used to predict the weather. And there's actually research out of Israel that professors have demonstrated this. So it's a pretty small delta for a telco provider to do this. But of course, it's not worth their while because it doesn't drive their business and they don't see an end result. But imagine if the network itself was paying for this data. So you might ask, well, how does that work? And the answer is, it's basically using inflation. So Bitcoin, let's go back to Bitcoin. Bitcoin is actually this self-sustaining network out there. And there's tens of thousands of people running nodes. Why are they running them? Well, it turns out that if you add to the security of the Bitcoin network by running a node, by adding to the hash rate, then you have a chance of getting 12.5 Bitcoins. Every 10 minutes, you have a chance of doing this. The more security you add to the Bitcoin network, the more chance you have of getting these 12.5 Bitcoins. And that's pretty great, because that's about 100,000 euros. So Bitcoin is using inflation, it's printing Bitcoins in order to incentivize people to add to its security. Imagine that you have another public utility network that is printing its tokens in order to incentivize people to supply data for the commons. So now I'm a telco provider, and if I see that if I provide some of this data for weather usage or otherwise, I can be getting paid maybe $10,000 every 10 minutes for this data. And that's the idea here. So block rewards coming from this to incentivize the data supply. So Even though the data is free for consumers, the suppliers of the data can get paid. Pretty cool, huh? Finally, there's a third way, and this is a big challenge. Many of you have probably been thinking about GDPR, right? And inside a hospital, if I'm a friend of mine, he's a researcher using genetic programming to make models of cancer. And he tells me that he's a happy man if he has access to 100 data points from 100 people. And the thing is, he's got medical data. He's got, DNA data. So he's got thousands of input variables and only 100 samples. His models are terrible. He can hardly predict anything. And you know what this means is that these models of cancer, maybe they can predict cancer 6 months in, when you're at stage 3 cancer. But imagine if, instead of having 100 samples, you have 10,000 or 10 million or a billion samples. Imagine how much better the models can be, right? Instead of predicting 6 months in, maybe it's 6 days in. Instead of stage 3 cancer, it's stage 1 cancer. And of course, that sounds great, but you run smack into privacy issues, privacy laws, as well as simply ethics, right? But imagine instead where you can say, you know what, we're going to build these models, we're going to go to hospital number 1, and we're going to update the model from that. And then hospital number 2, and update the model from that. And do hospital to hospital to hospital, or even consumer by consumer by consumer, right? So this is the realm of federated learning. Now, traditional federated learning decentralizes the data, but you have a middleman that's orchestrating all of the learning, and you have a middleman that controls the final model. And of course, if you have a middleman that controls the final model, it can get reverse engineered, and then you lose all this private data, it leaks out. But imagine if all of it is decentralized, every single layer, at the level of the hospitals and the data itself, at the level of the orchestration, and at the level of the model itself. If all of that is decentralized, part of this public utility network, where every single person controls their own data, then you can actually untap the potential of billions of people's data sets for predicting cancer, for predicting Alzheimer's, and so on and so forth, and beyond medical as well. Self-driving cars, and so on. How do you do this? Well, the summary is bringing compute to the data. That is the core along the stack. Let's keep going. So overall, I've talked about this whole idea of this AI commons. You can frame it in various ways, as a compute pipeline, as decentralized orchestration, as Sabre for data. So just like when you go to buy airline tickets, all these different airlines are providing their data, whether it's Air Canada or Lufthansa and so on, but you get to access that same interface no matter what. And the reason is, in between, there is a unified database, Sabre and Amadeus together. Imagine if that unified database was there for all the data and no one owned or controlled it. That's what's possible now. Imagine if you're a data scientist, you get to keep using your own tools. You can use Jupyter, and that you can combine this with Web3 wallets, things like Ethereum and so on, or Apache Spark. And guess what? This is actually already running software, integrations with Apache Spark, and so on. Every single data set is an asset. Every Jupyter notebook is an asset. Every algorithm you write as a PhD student or researcher is an asset. It can be sold, or it can be given to the commons for free. This gives you new powers, way more data, like I talked about, data commons, or enterprises being able to sell their data without worrying about the data escaping. You get provenance in your data and AI training. This is critical for GDPR. GDPR requires that you actually can explain the data that you're providing to consumers. Well, what better way to have that if you can actually have a very clear trail of where all the data came from? Data honeypots. Every single big enterprise right now has a massive data honeypot. It's massive liability. You have huge costs for insurance. Imagine instead of that, where every consumer is just holding that data and they're giving permissions to the enterprises to access it for the benefit. So goodbye data honeypots. And of course, more dollars for anyone who's generating data or cleaning it, labeling it, doing feature engineering, and so on. I've talked about some applications, things like the satellite data to see the impact on water quality. Better predicting Parkinson's. So one project we're working with is based out of Munich and Singapore. And so it's 2 hospitals in Munich and Singapore. They're having trouble sharing the data in the traditional ways because of GDPR and so on. But now they can actually share the benefits of it by modeling at this higher level using this public utility network as the connective substrate. Grow Asia, it's a spin-off from the World Economic Forum. What they're doing is using AI to help farmers allocate their fertilizer better to increase yields and so on. As well as, for governments themselves, right? We have GDPR and so on. So the data authorities in the government of Singapore are actually using this technology to give optionality. Right now, we think it's a either or. You can either see, the government can see all the data all the time, and at the cost of privacy, like we see in China, Or you go the opposite direction, sort of like the status quo with Europe and GDPR, where it's hard for anyone to see anything. Imagine if you can have your cake and eat it too. That's what's possible now. So the German laws and European laws of GDPR can get reconciled. And this is actually what Singapore is doing. So with that, I will conclude with the following slide. What I've described to you is this overall goal of asking, how can we use AI for good? For good as in these KPIs for humanity, the UN 17 Sustainable Development Goals. It's happening. And now there's technologies to do this at scale, leveraging public utility networks. And around that, there's a foundation that has formed. It's a movement and a foundation called AI Commons. Many of the top AI researchers in the world are starting to join in as part of this. And last year, actually on stage, we had Fred Werner, who runs communications at the International Telecommunications Union, as well as many others, the X-Prize folks and others, basically announcing the AI Commons. It's been slow and steady growth since then. There have been workshops, and basically, this is a movement and a foundation that is driving AI for good at scale. So I encourage all of you to join this movement of AI Commons to change the world. And I will close with a question. Do you want to sell ads, or do you want to change the world? Thank you.